Hello and welcome to my final year project demo. This project is based on facial recognition attendance and surveillance system for face-to-face university exams. It is a smart exam monitoring system. For short, I call it SAMS. First, we're going to look at the aims and objectives of the system, what this project accomplishes, and the main focus behind it. Next, it is very important to understand the flow of the system, how it actually works, how data flows through the system, and different decisions that affect the system. And then finally looking at to the demonstration where we will see the most important features of the system, such as the authentication process, overview of the GUI, different type of users and their access rights and the actions that they can take. And then we'll get deep into the exam attendance and monitoring phase, where we'll run a pre-recorded video of an exam simulation. We will also cover features that are not shown in the video in real time, such as different liveness detection options, and some cheating detection options. In parallel, we'll also have a look at how and where important data during the exam monitoring is stored. The main idea of this project is to have a touchless and automated system capable of performing exam attendance and monitoring that is fully controllable via a GUI. It must also have an almost seamless flow between all the processes and phases such as face recognition, liveness detection, correct sitting detection, and cheating detection. Let's take a look at the system flow. In the first phase, students log in and choose to register their face biometric with or without face mask. 100 samples of face images is captured using the available webcam or camera connected to their device. These face images are stored on disk and a record is added to the cloud database, and the status of the user is also updated. The next phase is the training of the face recognition model. Only the lecturer has access to this process. Once the training starts, facial features of the facial images of each student are extracted and stored on a file. Let's say the phases during an exam. The first phase is the attendance phase. The lecturer switches it on. Students in a queue should each walk up to the camera in the smart device one at a time. Facial features are extracted from the captured face image and is compared to every template in the training file. After the identity of the student is established, liveness detection is performed. If it fails, the lecturer is warned, then the result is stored on the database. The footage is also recorded and stored. In the next phase, the system tries to determine correct seating. Depending on the configuration, the system assigns IDs to the seats. The system can also detect students and assign the corresponding ID based on the database. YOLO v5 is used as an object detector for both seats and person. The system then checks if the student ID matches the seat ID where the bounding box overlap, meaning they took the seat. If not, the lecturer can know beforehand. In the final phase, the system performs exam monitoring. The system automatically detects cheating by cell phone detection and head pose estimation. Pose classification is also used to detect hand raises. By default, a hand raise is associated with asking permission for a toilet break. Database is updated if cheating is detected or a toilet break event. Now let's move on to the demo. Let's run the main program. Once we launch the application, we are greeted by a login page. There are two types of users for this system. One is student and the other is lecturer. Lecturer credentials are initially set up and provided by the database admin. For students, they are required to register. They need to enter the email, password, student ID, etc. Before we log in, let's take a look at the cloud database we are using to store important data. MongoDB is being used, and you can see different tables we have in our database. The users table is where credentials are kept. Now, let's log in with the student credentials. In this screen, we can see that a student can register their face biometrics with and without face mask. Let's try to register. 100 face image sample is captured to be used for training for that student. If it is required, we can also register with mask. Now, let's log out and log in as a lecturer. Here you can see different options that a lecturer can choose. Let's start by training the model. A progress bar is shown as an indication. It then disappears when training is complete. Now let's run an exam so that we can test using the simulation video. We specify the name, the date and time, and also the seating arrangement. Since in the video we only had 3 student actors, we fill out the seats as required. It should be noted that all actors in the video already registered the face biometrics and have their IDs as we are assigning to the seats right now. On clicking submit, a new exam has been created with its configuration. Let's start the testing exam. We can also select different liveness options. Let's do passive. Let's click on start attendance and start correct seating. Another small window has shown. The window shows the top-down view of the exam venue and the seat status. A green one indicates a correct seating, a white one indicates an empty seat. The process is quite slow due to hardware limitations, as models that are very GPU and CPU intensive are being used. An orange seat indicates a wrong seat. It should be noted that after each attendance, the data is stored on the cloud database and the liveness process frames is also being stored on the disk. Since this process is slow, I'll skip to the important part. Now that all students have taken the seat, we can start the exam monitoring process. Head pose estimation model is used to detect if students are looking too much to the left or right. The system is also configured to provide some leeway. The second student is trying to cheat by looking too much to his left. The student is now blacklisted for cheating. Notice how the seat color changed to black. Now the first student is also blacklisted. A pose classification model is also used to detect raising of hands. The same yellow V5 object detector is being used to detect cell phones as well. Now that one student has raised his hand, the system prompts the lecturer. Surveillance stops on the student that is free to leave for toilet break. When the student returns and takes his seat, surveillance restarts for him. When the system is sure that a student is cheating, the student is blacklisted and surveillance stops. He or she is automatically disqualified. Upon ending the exam, a report is generated using all the data stored on the cloud database. Now let's try different liveness options in real time. First we have passive. Let's try it using a face mask. Second, we have blink check. The number of blinks required is always random. Thirdly, we have gaze check, which tracks the iris to determine the direction the user is gazing. Once again, the direction is randomized. And then finally, we have raised eyebrow detection. The system calculates the normal eyebrow resting ratio and prompts the user to raise their eyebrow. Let's also try exam monitoring in real time as well. We're going to use the same camera for both attendance and monitoring. After attendance, we can switch it off, and I'll need to go out of frame for the system to detect my seat. Now let us start the surveillance. We will try the unauthorized object detector, that is a cell phone. As soon as it detects my phone, I'm automatically blacklisted, as you can see from the black seat icon. That's it for this demo. Thank you for your attention.